Well, I hope you guys are staying safe from the coronavirus. So, what I'm going to try to do for the class the remainder of the semester is just give you a brief overview of each section and then try to do some of the problems in your homework. Okay? So, 7.1 deals with the idea of the normal density curve here, and we're going to look at some basic properties of the normal distribution. Number one and number two is important. Number three is probably the most important. And then number five. Excuse me, not number three, number four and number five. So one, two, four, and five. Number one says it's symmetric about the mean. So what that means is that the mean right in the center, and the area over here is a half, area over here is a half, total area is 1. All right, so let's go over and look at a couple of your homework questions. So is the normal curve symmetric about the mean? Well, yes, we just said that. So this statement is true. The mean is the balancing point for the graph of a distribution, and therefore all distributions are, well, that's not true. The normal curve is symmetric distribution with one peak, which has one mean, median, and mode, which are all equal. So this is the one you want here. The area under the normal curve to the right of the mean is a half, right? Half over here, half over here, half. Now, a normal density curve is just one in which it has one peak, like the normal bell curve, and the graph does not touch the x-axis. So this would be yes. And let's see if we can get one. That one would be no, as it touches right here, and it's not symmetric. Is this bell-shaped? If it's roughly bell-shaped, if you can roughly draw a bell curve, then it is bell-shaped. So the histogram is bell-shaped, so it's either A or C. So a normal distribution could not be or could be, so we're going to choose could be, used as a model for this variable. 7.1, by the way, is very short and quick. 7.1 shouldn't take you much time. Okay, which graph is which? All right, this is going to be pretty straightforward. Well, this graph, the blue one, has a mean of 13, and the red one has a mean of 6. So if you think about just drawing a line, straight down at 6, and for the mean of 13, then you can easily pick out which one is which. So graph A has a mean of 6. Graph A has a mean of 6, so it's either A or B. And graph B has a mean of 13 because a larger mean shifts the graph to the right. So basically, as you increase the mean from 6 to 13, this is just going to shift over. If I shift it from 13 over to 20, you're just going to shift it over some more. If I shift it to the left from 6 down to 2, then it's just going to shift over here to the left. So we would choose A as the correct answer. Here we'll pick out the mean. Okay, so the mean here is right in the center. That's minus 11. And the standard deviation, if you just want to think about subtracting 9 from 11 is 3, 2. Each time is 2, so 9 to 11 is 2, 11 to 13 is 2, 13 to 15 is 2, etc. So standard deviation is 2. Now let's do another example like that. So this time 15 is the mean. Standard deviation again, just take 19 minus 15 is 4, 15 minus 11 is 4, 11 minus 7 is 4, and each time we subtract a higher number from a lower number, we get 4. Okay, so let's do another similar question. Make sure you get this. So 18 minus 20 is 2, 20 minus 22 is 2, 22 minus 24 is 2, and so this time we get 2. So the mean is right in the center, minus 20, and then standard deviation is 2. I'll do one more here. 6 is the mean, and then again 6 minus 1 is 5, and then 1 minus 4 is 5, and then minus 4 minus 9 is 5. So again, the difference between each of these numbers here is 5. So you should get the hang of it. Okay, so we'll do a couple more. So pick out the graph here. So 70 is the mean. So, well, there's only one that has a mean of 70. So that's going to be that one. All right, suppose monthly charges for cell phone plans are normally distributed with mean of 61. So that means 61 is going to go right in the center. So it has to be one of these. And then standard deviation is 18. So let's take 61 plus 18. And that gives you 79. So 61 plus 18 is 79. This is the one that you're wanting. And then this one is going to be 61, the average minus the standard deviation. So 61 minus 18 gives you 43. So this is the curve. And then part B, shade the region that represents the proportion of plans that charge less than 43. So again, pick out the curve here, 61, 79, and 43. 61, 79, and 43. There's only one of those, but so it has to be this one. But this one shows the proportion of cell phone plans here that are less than $43. So that's going to be that one. And then part C, suppose the area under the curve to the left of 43. So this area here to the left of 43 is 1587, provided interpretation. And so what that means is about 15 or 16% of all cell phone plans will cost less than $43. Right? So 15%, or another interpretation would be that if you randomly selected a cell phone plan from all the cell phone plans, then the probability of getting one less than $43 would be this 1587. So the probability is 1587 that a randomly selected cell phone plan in this population is less than, because we're talking about the proportion that's less than $43. So $43 more. Okay. All right, so I hope that this helps you with 7.1, and so this is kind of what I'm going to try to do for the rest of the semester, is give you a brief overview and then work through some of your homework questions for you. Okay. I hope this helps, and I'll see you on the next lesson.